Hi, hello, welcome to our channel. In this video, we will discuss about resistance. Okay, resistance of a material. So, resistance of a material is defined as a property of a material which opposes flow of electrons or flow of charges or flow of current through it. Okay, so resistance is nothing but opposing character of a body or a material. So every material or body has some resistance. Okay, so human body has also has some resistance. Okay, so resistance R is equals to V by I ohms. So resistance units are ohms. So this is derived from Ohm's law. Okay, so where R is resistance of a material, V is potential difference across that material, I is current flowing through that material. Okay, so there are some factors will affect the resistance of a material. That means if that factor changes, resistance also changes. Okay, so those factors are nature of a material, temperature, length of a material, cross sectional area of the material. Okay, so as temperature changes, resistance of that material changes. Different types of materials have different resistances. As length changes, resistance of that material as also changes. Cross sectional area changes, that material resistance also changes. Okay, so first let's see nature of a material, how nature of a material will affect resistance. Okay, so take three different types of materials, that is copper, aluminum and iron rods of same length and same cross sectional area. Okay, and make a circuit using components by a battery, an ammeter and a key. Okay, so with connecting wires, connect a circuit like this. Okay, so battery is supplies energy to the circuit and ammeter measures the current in that circuit, and purpose of key is to switch on and off this circuit. Okay, where P and Q are two terminals of connecting wires, free terminals of connecting wires, to which we will connect different types of materials. Okay, and now connect a copper rod and switch on the circuit and observe the meter reading of ammeter and note down the value of current. Okay, so and also note down the values of current in the case of aluminum and iron rods by placing these two rods at P and Q terminals. Okay, then you will get three different values of currents. Okay, so that means different materials have different resistances. Okay, next, effect of temperature on resistance. For that you need a bulb and a multimeter. Okay, so multimeter is used to measure resistance, current and voltage. Okay, so a multimeter can be act as a voltmeter to measure voltage, ammeter to measure current and ohmmeter to measure resistance. So that is why it is called a multimeter. Okay, so take a bulb and measure the resistance of that bulb by placing two terminals of multimeter at the two ends of a bulb and measure the resistance. Okay. To measure the resistance of bulb by using multimeter, set the multimeter in ohm meter mode and also set the knob at 20 kilo ohm. No, place 20 kilo ohm. Set the knob at 20 kilo ohm. That means 20 kilo ohm means, so that bulb resistance may be around this value. Okay, if the bulb resistance is around this value, nearby this value, then the multimeter reads its actual resistance. Okay, and if multimeter reads 0, okay, if multimeter reads 0, the resistance of the bulb is much lower than 20 kilo ohm. Okay, that means near to 200 or near to 2 kilo ohm. Okay, so for that case you have to set the knob to 200 ohm or 2 kilo ohm. And next, if multimeter reads 1 or OL, that means overload, that resistance is much higher, 20 kilo ohm. So that may be near to 200 kilo ohm or 2 mega ohm. Then set the higher, then set the knob to higher mode, either 200 kilo ohm or 2 mega ohm. Okay, so in this case we measure the bulb resistance when that bulb uh, is in open position, that means that is not connected in a circuit. Okay, so that measured resistance, note down. And next, connect that bulb to the battery through a key and switch on the circuit. After few minutes, measure the resistance of bulb by using multimeter by placing its terminals at the terminals of bulb. Okay, and note down. Okay, so by observing two readings in both cases, we can say that both resistances are different. That means first resistance is less than the second resistance. Why? Because in the second case the bulb is connected to the circuit. Okay, so it glows. So when it glows, that means the filament in this bulb is heated up, that means its temperature increased. So here temperature increased, that means that increased temperature will increase resistance of the bulb. So we can say that increased temperature will increase the resistance. So as temperature increases, resistance is also increases. Next, length of a material. So when length of a material changes, how resistance changes? Let's see. So take iron spokes of different lengths and same cross-sectional area. Okay, and connect a circuit using a battery, ammeter and key like this. Okay, so P and Q are two free terminals of connecting wires to which we connect different iron spokes. Okay, and then connect different spokes across P and Q terminals at for each spoke. For each spoke, note down the value of current. Okay, so after all the values taken down, you can notice that the values of current are decreased with increase in the length of materials. Okay, when the length of the material increases, when length of the material increases, current decreases. Okay, so current decreases. And what is the relationship between current and resistance? So current is inversely proportional to resistance. So current decreases. Inversely proportional means one increase, another one decrease. So current decreases, and so resistance increases with increase in length of the conductor. That means R is directly proportional to L. So as length of material increases, resistance of that material also increases. Effect of cross-sectional area on a resistance of a conductor. Okay, so how resistance of a conductor changes as a cross-sectional area changes. So take iron rods of same length and different cross-sectional area. And connect the circuit like this. Okay, so across these P and Q terminals, connect different cross-sectional area rods and note down the values of current for each case. Okay, connect different iron rods between P and Q terminals and note down current values for different iron rods. Okay. By observing current values, we can notice that values of current are increased. That means as cross-sectional area increases, current also increases. So current increases means resistance decreases. Resistance will decrease. So resistance is inversely proportional to cross-sectional area. R is directly proportional to 1 by A, or R is inversely proportional to A. So finally, we can say that the resistance of a conductor is directly proportional to its length and inversely proportional to its area of cross-sectional area. So R is directly proportional to L by A. So to remove this proportionality constant, R is equals to rho into L by A. So where rho is called specific resistance of a conductor. Okay, specific resistance of a conductor. Well, R is equals to rho into L by A ohms. Okay, thank you.